Okay, so let's get started. Hello everyone. I'm very happy to share the topic here. My topic is open standards for machine learning deployment. First, I'd like to introduce myself. I come from IBM. I'm Liu Honggang. I have been working in open source related items like OpenStack and also machine learning. Now I focus on AI solutions. I have two colleagues. One cannot attend today's meeting because of visa issues. So both of these two colleagues come from Center for Open Source Data and AI Technologies. So CodeDate aims to make AI solutions to enterprises and companies. And this involves machine learning and also the machine learning workflows, as well as the detailed treatment like data processing and also algorithm processing, as well as optimization and customized services. So today, we'll talk about one step of this whole workflow, that is model deployment. What are the challenges and how could we solve it? We have three parts today. I will introduce the background first, and then I will introduce the open standards for machine learning deployment, and then we will have the summary. First, let's talk about what's your first impression when we talk about machine learning. Maybe it will remind you of some bad robots who want to slaughter human beings, or those very good guys, like good robots, who will do good things to human society. I think machine learning is like a double sword. We learn from the data to make predictions, and then you generalize the rules. To be specific, we learn from the historical data to make predictions about the future. Or learn from historical data to make predictions about the future in order to make decisions. For the current machine learning, for example, for AI, I don't think it involves a lot of like human elements. Sometimes you can see in the movies some machines, they're friendly to human beings, they're not friendly to human beings. AI is more like an intelligent system. It's more like data processing and data match. It's just a complicated match and correlation. By using the current data to conclude the result and then give the feedback, and then you further adjust your model. This can be widely applied in smart city, smart farm, etc. Then I'd like to talk about the whole workflow of machine learning. You may think we have a lot of data, or the client's data, and then we build a model. We make predictions, and then we can sit there and wait for the results. We just wait for the results to come out. But actually, the actual process is much more complicated than what you have thought. It involves not only a person or a team, it involves multiple teams of different areas. It involves their coordination and cooperation to complete this whole workflow. First, you have quite a lot of data, especially in the information age. How to collect all those data, ingest the parts that you think is relevant to you. And I think for this part, we use big data tools like Spark, etc. And then after you get the data, you take this data to the lab, you write different kinds of models, you make predictions. I think that's your direct impression of machine learning. But it involves multiple steps and procedures. How to visualize the data, how to take out the features and transform. It's not easy. And then we train the model. And the model might have different architecture or structure, and then you need to choose. And you might have multiple versions of a model. And then you need to control the traffic, do the A/B test, etc. And then after the model go live, you need to think about how well it works. You need to think about its usability. It involves multiple teams, not only one team. And it's quite complicated. This graph is very famous, coming from Google. It reflects the true machine learning situation. You can see the black area. That is machine learning code. And then actually you spend most of your time on other modules. Like to maintain or to pre-process, after-process, real-time monitor the system. And last, we'll talk about how to deploy the model completely. That's maybe the final step, but it's one step sometimes you will neglect when you're in the lab. When we deploy a model, we need to think about 3 questions. First is, what are you deploying? Whether you use TensorFlow or other means. And then you need to think about where are you deploying, whether it's in cloud, browser, edge, and also need to think about whether it should be real-time or streaming. And last question is, how are you deploying? Whether you buy a certain engine, and how the model is presented. What is a model? It's like a document. You have the document, and then you can predict. Actually, it's not that way. Normally, a model still receive the data. Or sometimes when you upload a picture, actually the model only receives some data, because the model needs to do some pre-processing, and then it will output the data. And then the data would be transformed into a visible and identifiable thing, for example, a picture for the user. So actually we have the pipelines, not models. And you need to know what is involved for each pipeline. But we have some challenges. For example, different departments, they may use different languages. Like data scientists or researchers, they care more about what kind of problems will be solved by this model. They care more about the what. As for the performance of the model, actually they don't really care. But when it comes to, for example, production department, they will care more about performance. For example, they might need C language, etc. And also different departments might use different frameworks. How to make sure they can cooperate with each other seamlessly, that's a challenge as well. And also when you deliver the model for IT department, they hope you can have as less challenges as possible, and also the changes could be under control. But for researchers or data scientists, they need to make sure that their model is the latest one. But for business department, they don't really care whether it's based on container or other things. They care more about whether this will create any profits, bring a stable performance to the clients. So we need to reduce the differences or differentiation as much as possible, and to make sure different departments can work seamlessly without these gaps. And that's the challenge. So for example, I like to use TensorFlow, and others like use Touch. Because I use TensorFlow, and others use PyTorch, and we don't have a unified standard. And then you have different customized ways. Then in the future, you need to have a system that can support both of these different tools or languages. And that will increase the complexity.
So a container that can solve these problems. And containers can give us packaging solutions and also make deployments. They're easy to configure. And also they're easy to repeat. And also different departments like to use their own methods, and they are compatible. But what about the performance, the final performance of this container? For example, a model written by Python can be huge, but the performance may not as good as another language. And also API, and also the formats. It involves some issue of standardization. For example, different departments use different models. But if Department B needs to learn from Department A, and if they can transform from each other, then that will be easier. So we need this standard. So why do we need a standard? Because all these models are transformed into a standard format. Like when we were small, we learned math. Now it's a universal language for all over the world. But for the Chinese, traditional mathematics, which are exclusive to our own culture, might not be applied to other countries and other people. Because a unified standard can bridge the gaps between different formats and different models, different languages. With this unified standard, we can use the same optimization stack. We can use a single stack and use the same tooling, which makes it easier. So now here comes our first open standard, PMML. It's based on SML. It was first developed and released in 1997 by a group. IBM was one of the members. PMML came very early, and now there are more than 30 vendors and organizations using it, mainly focusing on machine learning. And during, but the Spark process does not support this format. But other exporters can do it. And also a scalar and R. And XGBoost and LightGBM also support their models transforming into PMML. Here is a format overview. There are a lot of metadata information in it. There's the names and formats and versions. And it's friendly to our users and also apply to various scenarios. Now it supports the following algorithms, as you can see here, but it has a problem, one shortcoming, that is too standardized. That along with time, we might need other things beyond the standardized aspect, and which cannot be met with PMML, such as custom plugins. For example, if a plugin was written by Scala, it cannot be transformed into this PML format because it does not support this new language. Also, there's a question of licensing. So for companies who want to commercialize it, they might have concerns that they need to pay attention. Now the second is PFA. PFA was developed to solve the shortcomings by PML. It was also developed by DMG, and it supports many customized functions. PFA was written by JSON. It's different from PMML. The input and output for PFA is different, and it supports deductions and additions, and also mathematical methods, and also machine learning algorithms. And it can transform a PFI into a schema plus algorithms and small functions. And since it was written in JSON, so the cross-language functions work very well. It's a very easily usable user case. The input and output are both very easy. And also PFA supports two different status, such as cells and pools. A cell is a named value acting as a global variable used in an action. And pools, it's closer in the concept to a database, and it can be shared across action executions. PFA function database is abundant, including mathematical methods and also machine learning algorithms. And also it can do self-inspection and static inspection. And most importantly, it supports our mostly used languages, which PMML does not support. But PFA also has its shortcomings since it's a newcomer. It has some limitations. It was projected by Open Data Group. So it covers scoring for PFA in JVM and Python and R. Well, the advantages as to what PFA can do well are the type systems and also the flexibility and also machine learning. But it does not support deep learning well. It does not support for generic tensors, and also no awareness of GPU. The tests are limited. So this is a tool for IBM internal open source development, and also a tool for input and output. To leverage FA and Spark ML. Now that Arc is open sourced, and we welcome everyone who is interested to contribute to it. It's developed by Scala. And maybe in the future we'll do some testing, which to test if it can support deep learning. Now the last one is the Open Neutral Network Exchange. It's supported by Facebook and other big platforms. It's for computing graph. And now it also has a subsidiary project focused on deep learning and tensor operations. Now, so with the release of the ONNX model, so many other platforms need to give us more support. In the ONNX input and output, and runtime, we're also supported by Tencent, and here are also other supported tools Maybe you want to focus on TLM. TLM is a machine learning stack which can give further processing. Now it only supports static processing and cannot be used for further training, which we must improve in the future.
To summarize, it's very mature ML standard, but it has good support for standard machine learning models and feature processing. But it's relatively new compared with PMML. It's highly customized. And it can do pre-process and post-process. ONNX is a relatively new, but it could be very good deep learning standard in the future. So in summary, open standards for serialization and deployment, I think that's necessary for the current market. But of course, different standards all have their pros and cons. It cannot, for example, a single open standard cannot cover all the items of machine learning. There is no open standard which can cover all the problems or items. So now we're thinking about how to apply these different standards into different scenarios, or to use them as a portfolio to solve the problems, to solve the client's issues. So that's all of my presentation.